Welcome back to Math 171 Pre-Calculus Algebra. In this video, we're going to take a look at the intermediate value theorem and use it to find a way that we can put a bound as to where a zero might be located. So the big thing with the intermediate value theorem does introduce the idea of a continuous function. And if you go on to take calculus, you will get a broader sense of what a continuous function is. For our sake, we're just going to say a continuous function is something that I can draw without picking up my pencil. Now, like I said, in calculus, you will get a more rigorous definition of a continuous function, but this is going to be enough for our purposes. So now that we've drawn this function, I'm going to pick 2 points on here. Here, we'll call that A, and we'll call that B. And we're going to note that f of A is less than 0, and that f of B is greater than 0. I do want to point out this also applies if I chose A prime and B prime there, where we have f of A prime is greater than 0, and then f of B prime is less than 0. Just so long as they have opposite signs. What the intermediate value theorem tells us, for the purposes that we're going to use it, because the actual intermediate value theorem is a little bit more broad than this, it says if f of A and f of B have opposite signs, then there is at least one value of C between A and B for which f of C equals 0. So in essence, what this is saying is if I draw the function and I'm looking at 2 points and the sign changes in there, so one of them is positive and one of them is negative, I know that somewhere in between those two values of x, there has to be somewhere that it equals 0. And of course, a calculator can do that for you. But we can also just get an estimate on it. And sometimes we can even just work with getting better and better estimates. But for our purposes, we're just going to remember there has to be a 0 there somewhere. So for example, if we're given the function f of x equals x cubed minus 2x minus 5, I can note that f of 2 is equal to 2 cubed minus 2 times 2 minus 5, or 8 minus 4 minus 5, which is equal to negative 1. And then f of 3 is equal to 3 cubed minus 2 times 3 minus 5, or 27 minus 6 minus 5, which is going to be 16. So we can see that sign changes between 2 and 3. So therefore there has to be a 0 somewhere between 2 and 3. And if you were to punch this out in a graphing calculator, it would tell you that there's 0 at 2.0945515. But the important thing here is there has to be a 0 there somewhere. So that will conclude this video. In our final video for the day, we're going to talk about turning points on a polynomial.